Hello, hello, and good morning. So today we are going to extend off of what we've talked about as far as defining and exploring circle properties of circles. And so far we've talked about the equation of a circle, and we've talked about angles inside of a circle, outside of a circle, etc. So now what we're going to talk about is tangent lines and what they have to do with circles. So a tangent line is any line that touches exactly one point on the circle's circumference, and we call that the point of tangency. Okay, so this line is going to extend outward from one point on the circle's circumference. Okay, so that is what a point of tangency, the point of tangency is, and the line is the tangent line. So when a line intersects a circle at a point of tangency, the tangent line and the radius, so if I was to extend my radius from A to B here, what do you notice happens between the radius and that tangent line? Some of you might have already said that they are going to be perpendicular. Okay, and what does it mean again to be perpendicular? It means that two lines are going to intersect. Okay, so our radius and our line of our tangent line are intersecting, and they're forming right angles. So these here are going to be right angles. Okay? So when two lines are perpendicular, what do we know about their slopes? This is something that we've talked about in a previous unit, but when two lines are perpendicular, their slopes will be negative reciprocals. I'm trying to fit all that in here. Should have made larger lines. Okay, negative reciprocals of each other. Okay, and what that means is if the slope of one line is, let's say the slope of our radius is 1/2, okay, then that means that the slope of the tangent line will be a negative reciprocal. So it'll be negative, and then what is the reciprocal of 1/2? It would be 2 over 1, which is 2. Okay, so that's what it looks like to be a negative reciprocal. So your radius is going to have a slope, and your line of tangency is going to have a slope. And both of those slopes have to be negative reciprocals of each other. If the slopes are negative, this kind of goes without saying, but if the slopes are negative reciprocals, then the line is going to be tangent to the circle. If the slopes are not negative reciprocals, then the line is not tangent to the circle. Okay, so that's very important. So going back on how we find the slope of a line, okay? If you're looking for the slope of any line, it's going to be rise over run. So think about how much, let's talk about in this particular example, let's look at the slope of the radius. So here is my radius, AB. So I'm looking for how much it rises. And if you notice, it goes up 2 units. Okay, so that's my rise. And then my run is that it goes to the right 4 units. So my slope is 1/2. Now, in order for the tangent line, for the line to be tangent to the radius, it's going to have to be a negative reciprocal of that. So we know that if the slope of the tangent line has to be -2. Okay, well, let's see. Let's look now at the tangent line. Okay, so I'm looking at from point E to point B here. You can pick any line, any point on this tangent line, or what is supposed to be the tangent line. Okay, so let's look at how much we rise. Okay, and we're going to rise 4 units. So 4 units. And then what is our run? So then we go to the -2 units. So our slope is -2. So these are tangent to one another. So now let's talk a little bit about what can be formed from tangent lines. Okay, and The most important thing that is formed from a tangent line is what we call a circumscribed angle. Circumscribed angle. And a circumscribed angle is created by two intersecting tangent lines. So this is a tangent line, and this is a tangent line. And that angle right here is what we call the circumscribed angle. And the vertex sits outside of the circumference. Notice how it is outside of the circle. Okay? So when a line intersects a circle at the point of tangency, the central angle, remember that the central angle is formed by the center being the vertex going to 2 points that are on that line. So this right here is my central angle. And the relationship between the central angle and the circumscribed angle, so this angle here, and then our circumscribed angle here, are going to be supplementary. Now, if you don't remember what it means to be supplementary, you need to look that up and write that note out to the side somewhere. But to be supplementary, it means that they are going to add up to 180 degrees. So again, we know that the circumscribed angles have to sit outside of the circle's circumference. They are not going to be inside. But the vertex of the circumscribed angle, so this, let me erase some of this here. So this is my vertex, what is in purple, is the vertex of the circumscribed angle. And it is always going to be equidistant to each point of tangency, meaning that it's equidistant to this point B here. So this is going to be equidistant to this, okay? Those are going to be the same distance. So with that said, I'd like for you to pause this here so that you can be able to try these examples before I move on and give you the answers to them. And then you can come back here and check what they are. But I would really like for you to do these first. So for number 1, if RT is tangent to circle Q at the radius QR, so QR is my radius, meaning that QR and QS are actually equal. They are both 5. So we're looking for the length of QT. Well, from the thing that we just noticed, we knew that T is our circumscribed angle, or the vertex of our circumscribed angle. So we know that the distance from RT must be the same as the distance to ST. Okay, so QT is going to be 13 centimeters. Okay, for our second problem, in the figure to the right, the following statements are true. JK and LK are tangent. So JK is tangent, LK is tangent to circle C. Arc ML measures 138 and angle K measures 40. So we're trying to figure out what angle M is. Okay, so in this case, angle M is going to be 70 degrees.